Okay, so first of all, in order to use this software, I need to have the IDL software, which is also called the IAU software, downloaded. I need to have .NET-CDF files, and I also need to have an MS info file. Since I have all of those things, I can now get started. And I'm going to switch on the software, and I'm going to press this. Then I'm going to press click to continue. And here is my first box, and I need to change time axis format from minutes to seconds. Then I need to go to File and Import Files and select the second one, Algent QPMS files. Then I am going to go to Windows C, and I'm going to open up a file of .NET-CDF files, and then I'm going to select the ones I want, which are down here somewhere. I want 2017-08-16. I'm going to get all of the files from this day. I'm going to select them all, and then I'm going to select Open. Then I'm going to go to Data Analysis, Peak Integration /noise. And now I'm going to go to my MS Info files, and I'm going to find the file that I want, which is this one, and I'm just going to open it. And now here is my second box, and I just need to change anything on here in order to get my two graphs to open up. So I'm going to change my delay from off to 0.25, and here are my two graphs. So the first one is the noise calculation, and then the bottom one is the peak integration. So in this box here, first of all, I have the chromatogram, and this is all of the .NET-CDF files that I just downloaded. So I did them all for one day, and on this day there happened to be 17 samples run. Then there is substance, and this contains every compound that I included in my MS info file. And then there is the fragment M/Q, and this includes every ion for whatever compound I'm looking at the time. So in this case there are 2. For others there will be only 1, or sometimes there are more than 2. Then there is flag, and this will tell me what sort of integration has happened. So at the moment I haven't integrated anything, so it's 0. And I will never need to change this myself. It will change automatically, at least most of the time. Sometimes I do change it myself. But if I change it to 1 now, that means that it is integrated, and you can see this has now changed. If I change it to 2, this is integrated manually, and this is what shows up whenever I integrate something with different settings to all the other samples on that day. Then -1 is what happens when it can't find a peak, and then -2 is bad peak. But the software is really bad at identifying bad peaks, so I almost never get a -2. I'm going to change this back to 0 now. And then the delay is how quickly it will flip through my samples. So there's 17 of them, and it will go through them one after another. And at the moment it's going to go through them at a rate of 1 every quarter second, so quite quickly. And I can change this to either 1 every half a second or 1 every second if I want to slow it down and see more detail. Then the next thing is the retention time, and this is the beginning of the retention time. So at the moment it is 771, and this is just where the x-axis begins on the chromatograph, so right here. And then the retention time end is 828, and that is where the x-axis is ending in this window, just here. Then I also have, this is the peak integration section. So for method is Gaussian fit, And while there are other options, this is the only one I ever use. I never change it. Then there is baseline fit function, and this is linear, and I also never change this. It is also linear. Gaussian fit just means that it is searching for a perfect, well-distributed peak. And then sigma left and sigma right. What this means is that for a peak, the height of the peak, which in this case is between the two red lines, and then half that height is the green line in this case, and then the width of the peak is between these two green lines at the moment, and this is the half height peak width. And so in this case, the sigma left is 9, which means it's 9 times whatever the half height peak width is. And in this case, sigma right is 15, and that means it is 15 times the half height peak width. And this will obviously always be a different amount depending on the size of the peak that I'm looking at. Then I have apply settings here, and if I click this, it will now do an integration just for the sample that I'm currently looking at. So the black peak is obviously the result that the instrument actually produces, and then the red peak is the software trying to convert the size and height of that peak into a perfect peak. And I want the difference between the red peak and the black peak to be about the same for every sample. Then the blue and the red dashed lines are the baseline, and then the black line, which is kind of difficult to see, is the part I'm actually controlling. So if I change this to 20, you can see it's now sticking out the end. And then if I change this to something really small, it's now only going up to here and is only part way through the peak. So I need to change the sigma to make it as long as possible, to include as much of the baseline as possible, which makes a better, more reliable integration. However, I don't want the sigma to come into contact with any other peaks. Sometimes there are other peaks in the chromatograph. If there were one here, for example, I would have to make this a bit shorter. And also, I don't want the black line to ever go outside the window. So if I made this 15, it would now obviously be integrating over here, and I don't want that to happen. And also, if I had a peak very close to the other end, the same would be true for the right sigma. Now I have apply settings to all here, and when I click this, it's going to scroll through each of my samples. So in this case, I have 17 samples, so it's just going to go through them each in turn and apply the settings that I have set to each of them. So I'm going to click this, and you can see it's now scrolling through each of them. The number here is changing each time. Okay, and what I'm looking for in this case is that the red peak and the black peak are about the same amount of difference each time. And then I'm also checking to make sure the black line doesn't cross over outside of the retention window at any point. If I change these settings, or if I change the retention time and I mess it up and I want to change it back again, I can reset to default, and that will just do it for the sample that I'm looking at. And then I can also reset all to default, and that will change all of the samples back again. And you can now see my flag says 1 because it has been integrated. Also, we're just going to have a look at this one. And this is my blank peak, so every single day we'll have one blank run on it, and that is why this peak looks different to all of the other ones, but that's totally fine. Now I have the noise calculation. So this is looking at a piece of the baseline and comparing how variable it is to the size of the peak. So because even though this looks like a completely straight line here, there is a little bit of variation in it. So I want my noise calculation to be a small period of time just before the peak. And so in this case is 768, so that's where it starts. So it's starting here, and then it's going to 774, so it's ending here. And what I want to make sure with these selections are that it is as close to the beginning of the peak as possible without actually including the beginning of the peak. And sometimes the peak will be too close to the beginning of the window to be able to do it here. So I would have to do it afterwards. But when I do it afterwards, I want it as far away from the peak as possible. Because usually with every peak there's a little bit of tail at the end, even though it can't be seen on a graph this small. So I need to avoid it by going as far away as possible. Now, for the noise calculation, it needs to be at least 6 seconds long. So you can tell the difference between these two numbers is 6. If I tried to do a noise calculation with less than 6 seconds, it would still give me a result, but it would also give me a warning telling me I'm doing a noise calculation over a really small period. And I would usually aim for the length of the noise calculation to be about 10 seconds, and probably going up to something like 15 seconds as the largest I would do it for. So if we have a look here now and I apply settings, I want the red lines and the blue lines to be as horizontal and as flat as possible. And you can see now the window's snapped, so this is 768 and this is 774 just here. And then all of these buttons are the same as these ones here. They just work on this window now. So if I apply settings to all, it's going to scroll through each of them in turn. You can see the number here is changing again. And if I had changed the noise to something that I didn't like, I could reset to default just for the sample that I'm looking at or for all of the samples that I have. So now that I've done both the peak integration and the noise calculation, I'm going to go up here to report, and I'm going to select this one here. And now I'm going to save my file as a text file. I'm just going to save it in desktop, and I need to name this something so that I'll know what it is. The software automatically calls it whatever the compound is that I'm looking at, but I am also going to put the day in here and then an underscore, so that's the date just here, it's also here. And then if I also do an underscore after the compound, and I'm going to put 67, which is rounded up to a whole number, what this number is, so I know what the iron is that I am using. Then I'm going to save this,